So let's continue our work with the unit circle by looking at a few examples. Using the unit circle, evaluate each of the trigonometric functions. So let's slide over here, and let's say there. All right, so let's do the sine of 420 degrees. Now at first glance, you'll probably notice that, wait a minute, 420 degrees is not one of the angles on my unit circle. Or is it? So what we need to do, let's make a little arrow here. And we notice that we start at 0 and we go all the way to 360. Well, 420 is 60 more than that. So we have to not only go around once and then keep going 60 more, so we wind up here. And so actually, the sine of 420 will be the same as the sine of 60. And we remember the sine is the y coordinate for that point. So our answer is just going to be the square root of 3 over 2. So 420 is coterminal with 60. Let's do another one. How about the cosine of 10 pi over 3? Now here we're in radians, so that's 1 pi over 3, 2 pi over 3, etc., etc. We go all the way around once, and that's actually 6 pi over 3, which equals 2 pi. So we still need to go 4 more pi over 3's. So we got 6 pi over 3 after we went around once, and now we need to go 4 pi over 3, which is right down here. So this is the point that's coterminal with 10 pi over 3. And to find the cosine, we know that's the x-coordinate. So we get negative 1/2 for our answer on that one. Now, it might help, instead, if you don't like the visual approach to that, you can think of it a different way and say, well, 420 is more than 360, so if I subtract 360, oh, that's really the angle that I'll be at after I go around the circle once. And if it happened to be a really big number, like 750 or 1,000 or whatever, you can just keep subtracting 360s until you get down to a number that's between 0 and 360. Likewise, if it's in radians, do the same thing. We have 10 pi over 3. We know that's more than 2 pi, so let's subtract 2 pi. Well, in order to subtract these, I need to have a common denominator, so let's rewrite 2 pi as 6 pi over 3. And that leaves us with 4 pi over 3, so I know, oh, that's the angle that I'm really looking at. All right, let's keep going. How about the tangent? Let me erase these so we don't cloud it up. How about the tangent of negative 5 pi over 4? Now we're going in the opposite direction. So if it was just 5 pi over 4 and I go counterclockwise, I know I wind up right here, 5 pi over 4. So think of that visually, starting here, going all the way around to that middle point there. So if it's a negative 5 pi over 4, we're going to go the other way, and we would wind up right here. So it turns out it should be the same as positive 3 pi over 4. The tangent is going to be the sine over the cosine, or the y over the x. So it's going to be positive root 2 over 2 divided by negative root 2 over 2, which is going to give me simplified negative 1. Now, if you want to do it the other way, like I talked about, you can take negative 5 pi over 4. Now, since that's negative, what if we add 2 pi to that? But we'll have to make that 8 pi over 4 in order to add those two together. And notice that gives me 3 pi over 4, which is exactly where I was at. So a couple different ways to think about it when we get these angles that are not angles on the unit circle, but they're coterminal with an angle on the unit circle. Secant of negative 30. Okay, so I'm going to go a little faster. So negative 30, I know positive 30 is there, so negative 30 is going to be right there, which is equivalent to 330. The secant is 1 over the cosine. Let's see, the cosine was the x value, so the secant is going to be the reciprocal of that. So it's going to be 2 over root 3. So 2 over root 3, and I'm going to rationalize this, so I don't have a square root in the denominator. So my final answer will be 2 root 3 over 3. Okay, how about cosecant of negative 5 pi over 6? First of all, let's get to the proper angle. So positive 5 pi over 6 is right here. So negative 5 pi over 6 is going to be right here, at this spot. Now the cosecant is 1 over the sine, or the reciprocal of sine. The sine is the y value, so the reciprocal of that is going to be negative 2 over 1. And so that's my answer. I'll just leave it as negative 2. And let's do one more. How about the cotangent of 870? Holy cow, it's a pretty big angle. So let's see. All the way around once is 360. Another time around would be 720. And I still have another 150 to go. So that would take me right to here. And the cotangent is the reciprocal of the tangent. We know the tangent is sine over cosine, so the cotangent will be cosine over sine. So cosine divided by sine. Negative root 3 over 2 over 1/2. Negative root 3 over 2 over 1/2. The 2's cancel. So that's going to give me negative root 3 over 1, or just negative root 3. And that's it. Now, once again, like I had mentioned earlier, for 870, if I got a room to write it over here, 870, if I subtract 360 from that, I have 510. That's still more than 360. Let's subtract another 360, and I get 150. And then that's the angle that I go to. All right, let's look at a different type of example. This says, find the angle theta in both degrees and radians. And notice that my answer is going to be between 0 and 90 degrees when I give my answer in degrees, and it'll be between 0 and pi over 2 when I give it in radians. So this is telling me that the sine of an angle is the square root of 3 over 2. Which angle in the first quadrant is that? Where is the sine equal to root 3 over 2? So I take a look at the unit circle. The sine is the y value. So when does the y equal root 3 over 2? Right there. So my answer is going to be 60 degrees, or pi over 3 radians. And that's all you have to do. So we're kind of working backwards from what we were doing a few minutes ago. So theta equals 60 degrees, which is pi over 3 radians. Okay, how about another one? Where is the secant equal to 2? So, wait a minute. The secant is a reciprocal of the cosine. So that means that the cosine of the angle must equal 1/2. So where is the cosine equal to 1/2? The cosine is the x-coordinate. And so the x-coordinate equals 1/2 right there. Actually at the same angle, 60 degrees, or pi over 3 radians. That's when the cosine is 1/2, so the secant would be 1 over 1/2, which is 2. So we wind up actually getting the same answer for this. So theta is 60 degrees, or pi over 3 radians. All right, let's look at one more. Find the angle where the tangent is square root of 3 over 3. This is going to be a little trickier, because when you look at the unit circle, we know the tangent is y over x, or the sine over the cosine. So we need to know, when we take the y divided by the x, it simplifies to give us square root of 3 over 3. So after you do these for a while, you'll start to remember this, but for now, if I just check 0 over 1, that's not square root of 3 over 3. 1/2 over the square root of 3 over 2. Let me check that. If I did 1/2 divided by root 3 over 2, the 2's would cancel, and I'd get 1 over the square root of 3, And then if I rationalize that, sure enough, that gives me square root of 3 over 3. So that's going to be my answer right here, 30 degrees or pi over 6. If I had tried this one, when I do the y over the x, I get 1. So that's not it. And here, when I do y over x, the 2's cancel, and I'm going to get square root of 3 over 1. So 30 degrees is my answer. So theta is equal to 30 degrees, which is pi over 6 radians. And that's it. All right, let's look at one other example, and it's closely related to this one. This time, though, I want you to find the angle, but now I'm looking over the entire unit circle, so the first, second, third, and fourth quadrants. And so that's a slightly different idea. So I'll show you what I mean. When is the cosine equal to negative root 3 over 2? Let's make a little arrow here. All right, the cosine is the x value. We know the x is going to be negative in the second and third quadrant because from the origin, left is negative for x. Negative root 3 over 2 happens right here, 150 degrees. But straight down, that's the same x value, also at 210. So notice there's actually two places on the unit circle where the cosine will be negative root 3 over 2. In the last example, they just wanted you to look between 0 and 90 degrees. So we didn't have to focus on, oh, the sine is equal to 1/2 at 30 and it's also equal at 150. They just want us to focus there. Now we're opening it up for the entire unit circle. So the cosine is negative root 3 over 2 at 150 degrees, or 5 pi over 6, and also at 210 degrees, or 7 pi over 6. And they wanted the answer in degrees and radians, so we'll say, let's see how I'll write this. Maybe I can fit it underneath here. Yeah. Theta equals 150 degrees, and also 210 degrees, which is 5 pi over 6 radians, and 7 pi over 6 radians. Okay, let's try another one. And by the way, it's always a good idea to hit pause, try it yourself, and then check your answer with my answer. Cosecant is equal to square root of 2. Before I try and figure this out, let's figure out, first of all, the cosecant. Use green. The cosecant is 1 over the sine. So that means that the sine of theta must be 1 over the square root of 2. Now that doesn't look like any of my coordinates, but if I rationalize it, multiply by root 2 over root 2, then I wind up getting the square root of 2 over 2. And that certainly shows up on some of my coordinates. So when the cosecant is root 2, the sine is positive root 2 over 2. So now I want the sine to be a positive value. The sine is y, so I know that happens in the first and second quadrant. So when is the sine equal to root 2 over 2? Right here, 45 degrees. And straight across here, 135 degrees. The y coordinate for both is square root of 2 over 2. So those are my two answers, 45 and 135. So theta, let's switch to red, and theta is equal to 45 degrees, and also at 135. And in terms of radians, that would be pi over 4 and 3 pi over 4 radians. All right, let's try one last one. When is the tangent equal to 0? Now remember, the tangent is sine over cosine, which is the y over the x. So if this fraction is going to equal 0, that means the top has to be 0. And the bottom can be any number besides 0. So I'll just put a squiggly there. So asking when the tangent is 0 is really asking when is the sine equal to 0? So if we look at our numbers, the sine is the y value. Well, that happens here. The tangent would be 0 over 1, which is 0. And it happens over here. 0 over negative 1 is also 0. So the answer is 0 and 180. So theta is equal to 0 degrees, or 180 degrees, which is 0 radians, or pi radians. And that's it. So you should be able to use the unit circle to find sines and cosines and tangents and cosecants and secants and cotangents for any of the angles on the unit circle or any angles that are coterminal with the angles we have on the unit circle. And you should also be able to work backwards. If you know what the value of the trig function is, you should be able to find the angle between 0 and 360. And sometimes it'll happen more than once, depending on the problem.